Hey everyone, here's another example using forces and Newton's second law for you. In this situation, we imagine that we have a block that's up against some wall. I'll just make a quick sketch here. It's a 3 kilogram block, and we're applying a force like this onto it. That's a 50 Newton force, and it's just 5 degrees offset from horizontal. And then the question is asking about the frictional and normal forces that are keeping the block in place there. So on this one, let's start with a free body diagram, as we always do. And let's try and do this the way that we'll do it on the AP exam, where we have a pretty diagram and we have a working diagram. The pretty diagram, we don't show our components of forces or anything like that. So our pretty diagram, first off, we've got, well, that force that's shown is 50 newtons, like this, and that's a 5-degree angle right there. What other forces do we have acting on this? Well, I see we're pushing it to the right, but it's not going through the wall. That must be because there's a force from the wall here that's coming out perpendicular to the wall, or normal to the wall. Oh, yes, that must be a normal force then. It doesn't tell us specifically that this is on or near a planet or moon, but it doesn't say otherwise, so we'll assume that there's gravity involved, and that's a downward force. Force of gravity, there we go. And then let's see what else. There is friction acting on this block because it's in contact with the wall. Now that friction opposes motion, so we need to think about, well, which direction would this thing move if there were no friction? And, you know, at this point, I don't really know. We've got a little bit of an upward force. We've got some downward force too, though. So if we get rid of friction, I'm not sure whether friction is going to be an upward force or downward. I'm not sure whether it would move upward or downward. I see that not very much of this 50 newtons is upward, so I'm just going to take a guess that friction is going to be pointing upward. Now, here's the cool thing. It doesn't really matter if we guess right on this. If we're wrong and friction is actually acting in the downward direction, when we calculate this, we'll just get a negative value for the force of friction. Hey, that's neat. Okay, we also know here that we have 3 kilograms of mass, but that isn't a force, so it doesn't go on the free body diagram. We know that it's at rest, not accelerating, but again, that doesn't go on the free body diagram. Okay, this is our pretty diagram here. That's our do not touch diagram. That'd be like part A on these problems, and they actually give you the instructions. Don't modify or add to your previous diagram. Do your work on a separate diagram. So let's take a look at our work now. The first thing I'll do in solving this problem is just make a new copy of my free body diagram. And this one I'm not going to use as my pretty copy that someone's going to assess. This is just for me to work on. So I'm just going to get myself a little space here, and I'll have the same forces on there. So force of friction, I think that's upward, but we'll find out. We got this 50 newtons. I'm just going to call that F1, just so I have something to call it for variables here. It's 50 newtons. And then I'm going to go ahead and break that up into its x piece and its y piece. And this will be F1x, and this will be F1y, and that's a 5-degree angle. And then we get our normal force out this way, and then gravity goes down. And I probably should make that gravity arrow just a little bit bigger. All right. Okay, so that's our force of gravity. Okay, now on this one, since I know that the thing is at rest, I can say also that acceleration is 0. The mass is given to me as well as 3 kilograms. I think it's useful to write both of those pieces out. Now that I've got this shown, you could probably just start by finding the x and y components of every force that you're given. Sometimes you end up wasting your time doing that if it turns out that you didn't need to solve for every one of those components. So instead, I'm going to start by writing out Newton's second law equation. Acceleration is equal to the net force acting on an object divided by the object's mass. And since my acceleration is 0, I can write 0 is equal to the net force divided by the mass. Well, the mass can't be 0 here. I'll just multiply the mass onto both sides. The only way for net force over m to be equal to 0 is if the net force is equal to 0. So 0 equals our net force. The other thing I can do with these, just like we did with projectile problems, anytime we have these vectors, so we can treat the x and the y direction separately. So I'll do that too. I'll say the net force in the x direction has to be 0, and the net force in the y direction has to be 0 too. Now, net force just means that I add all the forces that I have in that direction together. So in the x direction, I've got the normal force, and that points to the left, so I'll make that a negative Fn. And then I have the x component of the force 1, so that'll be plus F1x has to equal 0. In the y direction, I've got 3 of them. I've got gravity that's downward, so negative Fg, plus the force of friction, I think, is upward, but maybe it'll just come out as a negative value. That's fine. Plus the y component of that force 1 has to equal 0. Okay. Now, I can see here then that since I have spots in my equations for F1x and F1y, that I am indeed going to need to solve for those values. So just to keep it separate from the rest, I'll put in here that F1x in red is equal to 50 newtons times the cosine of 5 degrees. Whoops. Not 50 degrees, but 5 degrees. Okay. And that F1y is equal to 50 newtons times the sine of 5 degrees. And so that's going to give me values of 49.8 newtons for the x and 4.36 newtons for the y. Now I can take those values and plug them into these equations. So let's see, I've still got an unknown normal force plus my x component there is 49.8 newtons equals 0. And I'll subtract the normal force from both sides and get 49.8 newtons is equal to the normal force. All right, well, that's one of the questions. We still have to figure out, though, the force of friction. And so when I look over at the equation that has the force of friction in it, I see we have this F1y that's unknown and this force of gravity that's unknown as well. So I can't solve this equation unless I were to know let's see, force 1y is actually known now that I look at it. We have that 4.36. But we still don't know the force of gravity, so I can't solve for the force of friction just yet. But what I can do is say, back up here, force of gravity. Oh, that's a little ugly. Try that again. Okay, force of gravity is equal to the mass of the object times the acceleration of gravity. So the mass is 3 kilograms, the acceleration of gravity is 9.8 meters per second squared, so that gives us 29.4 newtons. Okay, so now I know we've got 29.4 newtons downward, plus force of friction, plus the y part of that applied force was 4.36 newtons, equals 0. So I'll add the 4.36 to the negative 29.4 and subtract those from the other side to the other side there. And what I get then is that my force of friction is equal to 25.04 newtons, and I do get a positive number on that one, so I was correct in thinking that that's an upward force. So force of friction here, and normal force. Always a good idea to go back and check what the question was, the magnitudes of the frictional and normal forces acting on the block. So for the normal force, we have that 49.8. The frictional force, we get 25.04 newtons, and we are finished. As you're solving these problems, please be sure that you do go through those individual steps. In particular, make sure that you start with this, the Newton's second law equation. In general, it's a good idea to start with one of the equations that's written on the equation sheet and then work from there to show them that you understand the concepts that are involved as thoroughly as you can, so they get the information that they need to grade it. That's all for this time around. Good luck on these problems. Thanks.